Welcome. Let's explore how science is fighting back against the imminent threat of global warming. We are going to delve into the dramatic strategies scientists are employing to capture methane, up to recently a silent villain in the climate crisis, and how we can halt or at least slow down what some say is the inevitable path toward the destruction of Earth through ever-increasing global temperatures. Methane is a potent greenhouse gas, and while it has a shorter atmospheric lifespan compared to carbon dioxide, it is much more effective at trapping heat in the short term. By capturing it from the air, we can address its warming potential and contribute to slowing down the rate of global warming. Methane is released into the atmosphere from various sources, including livestock digestion, rice cultivation, fossil fuel production, and waste management. The amount of time each molecule of methane or carbon dioxide remains in the atmosphere differs significantly. Methane has a relatively short atmospheric lifetime, typically around 9 to 12 years. Over this period, methane undergoes chemical reactions in the atmosphere, ultimately breaking down into carbon dioxide and water vapor. However, during its relatively short lifetime, methane is a much more potent greenhouse gas than carbon dioxide, meaning it has a greater ability to trap heat. Whereas carbon dioxide can persist in the atmosphere for a much longer time, hundreds to thousands of years. Some of it is absorbed by the oceans and vegetation, contributing to natural carbon cycles, but a substantial fraction remains in the atmosphere. But fear not, because scientists and innovators are on the front lines of a technological revolution. So what are the dramatic strategies that scientists have designed to capture methane and help break the chain of this climate crisis? Direct air capture, advanced filtration systems, nanomaterials, methane-consuming bacteria, and aerogel technologies are at the forefront. We're witnessing the birth of solutions that go beyond reducing emissions. They're actively reclaiming methane from the very air we breathe. These methods are not just theoretical. They are Earth's last stand against a formidable opponent. We have seen that where methane capture technologies are implemented effectively, they can potentially reduce atmospheric methane concentrations. And the positive feedback doesn't stop there. The data and insights collected from this research have not only contributed to improved climate modeling, but we now have a better understanding of how the different greenhouse gases in the atmosphere interact. But it is important to note that while progress is being made, large-scale deployment and measurable impacts on global methane levels may take time. Additionally, the effectiveness of methane capture initiatives is intertwined with factors such as energy consumption, economic viability, and the overall sustainability of the technologies. So, in this race against time, we've seen promising results, and early signs suggest that methane reduction can indeed make a difference. As we conclude this journey into the heart of Earth's last stand, remember that the fight against methane is a shared responsibility, and every captured molecule tells a tale of our commitment to Earth's survival. But capture is only part of the story. The time to act is now by implementing strategies to reduce methane emissions at their sources, such as improving livestock management, minimizing leaks from natural gas infrastructure, and optimizing waste treatment processes. Our choices today will shape the future of our planet. Look out for updates on this urgent mission to capture methane, halt the climate crisis, and secure a sustainable tomorrow. Thank you for being part of this critical conversation. Subscribe, share, and let's amplify the call for action. Together, we can make Earth's last stand the beginning of a new era for our world.